Ever tried mapping your whole city? Like every single street, every little park, all from inside your living room?
That's a tricky one.
Yeah. Well, that's what astronomers are dealing with when they try to study the Milky Way. We're stuck inside it.
It's like trying to put a puzzle together, but you're stuck underneath the coffee table.
Exactly. But here's the amazing thing. A powerful new infrared telescope just gave us the most detailed Milky Way map ever. We're talking 1.5 billion cosmic objects.
Wow.
It's like ditching those old blurry Polaroids for a crystal clear satellite image.
And what's incredible is this map. It's made up of 200,000 images.
Yeah.
Gathered over 13 years. Can you imagine? Talk about a long-term project. It's like going from those old hand-drawn maps straight to Google Earth. This is huge GE for understanding our galaxy.
So we're looking at the galaxy in infrared. For those of us who aren't astronomers, why is that a big deal?
Think of it like wearing a special pair of cosmic goggles. It's the visible light, the stuff we see with our eyes. It gets blocked by all the dust and gas floating around in space.
Ah, okay.
But infrared light, it cuts right through that cosmic fog, letting us see what's hidden. It's like having X-ray vision for the galaxy.
So what kind of secrets are we uncovering with this newfound galactic vision?
One mind-boggling find is the detection of something called hypervelocity stars. These things are incredible. Imagine this. Stars moving so unbelievably fast, they're actually escaping the Milky Way's pull, like breaking free from the galaxy's grasp.
Wait, seriously, they're like cosmic escape artists. What could possibly launch a star with that much force?
Imagine a cosmic pool table. But instead of pool balls, we have stars. And the cue ball is the supermassive black hole at the center of our galaxy.
Okay, I'm following.
One leading theory is that these hypervelocity stars got a little too close to the black hole
Uh-oh.
and got flung outwards with just incredible, mind-blowing speed.
It's incredible to think that something happening millions of light years away can teach us so much about, like, the universe's most fundamental forces. But this deep dive isn't just about, mind-blowing images. We've also got some really interesting articles about the Milky Way's, well, shape. Turns out, it's not your average spiral galaxy.
Definitely not.
It's actually warped.
Yeah. Picture a vinyl record left out in the sun for too long. You know how it gets a bit warped?
Yeah, totally.
It's kind of like that. Instead of a perfectly flat spiral, we've got these weird bends and twists.
So what could possibly warp an entire galaxy? I mean, are we talking like a cosmic fender bender of epic proportions?
That's the million-dollar question, right?
Mm-hmm.
It's a mystery. But there are two main suspects, let's say.
Okay, lay it on me.
Suspect number one, dark matter. That mysterious stuff we can't see directly, but which has this, like, massive gravitational pull. It's like an invisible scaffolding holding the entire galaxy together.
Right.
But if that scaffolding is, unevenly distributed, it could be warping the Milky Way's disk.
So something we can't even see might be shaping the entire galaxy. That's kind of spooky, but also amazing. What's the other suspect on our list?
Okay, so we've got dark matter possibly bending the galaxy out of shape. What was that other cosmic suspect?
Right. So the other possibility is ancient collisions with other galaxies.
Ah, like galactic bumper cars. Exactly. Our galaxy's probably had a few close calls over billions of years.
Yeah, it makes sense. Space is a busy place.
Tell me about it. And we're even talking maybe full-on mergers with smaller galaxies. These cosmic fender benders, they could have really messed with the Milky Way's disk, warped its shape over time.
So like a cosmic ripple effect, but over billions of years?
Yeah, something like that. And get this data from the Gaia satellite, that thing that's mapping billions of stars.
Yeah.
It suggests this warp isn't static, it's precessing.
Precessing. Okay. Need to brush up on my astronomy terms. What does that even mean?
It's like a wobble. Picture a spinning top about to fall over. That kind of wobble.
Okay, so we've got a warped galaxy that's wobbling like a top. Why is the wobble important?
It suggests the warp might be caused by, get ready for it, an ongoing interaction with another galaxy.
Wait, are you saying we're in a slow-motion galactic collision right now?
In a way, yeah. It's more like a gravitational dance with another galaxy.
Yeah.
This dance, it creates ripples, waves, and those waves, they warp the Milky Way's disk, causing that wobble we're talking about.
Well, that makes the Milky Way sound way more dynamic than I ever imagined. How do we even study something like that, a galactic warp?
That's where our new infrared map comes in.
Yeah.
It lets us see the warp in incredible detail.
Ah.
We can study the stars, the gas, the dust, see how they're all affected by this warp. It's like, how can I put it? Imagine a superpowered magnifying glass, and you're using it to study the patterns on a butterfly's wing. It's that level of detail.
So we're not just seeing a warped galaxy. We're seeing the aftermath of like billions of years of cosmic events.
Exactly. And this is where it gets really cool. These discoveries, they're like clues.
Ooh, a cosmic mystery.
Right. Clues about the Milky Way's past and maybe even its future.
Okay, how does a warped, wobbling galaxy tell us about the future? This is blowing my mind.
Think of it like this. The Milky Way shape, it's like a fingerprint.
A fingerprint.
Yeah, it's been molded by billions of years of cosmic interactions. The warp, the way stars and gas are spread out, those are all clues to how our galaxy was born, how it evolved to what we see today.
So it's like a crime scene, but on a galactic scale, and we're the detectives trying to figure out what happened.
Perfect analogy. And of course, dark matter is part of the mystery too.
Right, that invisible force shaping everything.
Exactly. Even though we can't see dark matter directly, this new infrared map helps us trace its influence. We can see how its gravity affects everything around it, like stars and those big gas clouds.
It's like trying to map a city you can't even see, right? By watching how the wind blows between the buildings, you can kind of tell what's there even if you can't see it directly.
Exactly. It's like using the effects of dark matter to map where it is. And the more we understand about how dark matter is spread out, the closer we get to figuring out the bigger picture of, well, the universe. Speaking of mysteries, though, what about those hypervelocity stars? We were talking about how they're like cosmic cannonballs being launched out of the galaxy, but some of them are moving so fast they should be long gone by now.
Wait, what? But we can still see them. How does that even make sense?
That's the billion-star question, isn't it? We're seeing stars that seem to defy everything we know about gravity, about how fast things need to move to escape the Milky Way. They should be out there in the vast emptiness between galaxies, but they're still here.
Okay, now I'm really lost. What could possibly explain that? Are we talking like new physics, unseen forces at work? I'm starting to feel like I'm in a science fiction movie here.
It's definitely a puzzle. But that's the fun part, right? Scientists are looking at a few different ideas. One thought is that maybe there's something else going on inside the Milky Way that we just haven't detected yet, like structures or objects that are affecting how these stars move.
Invisible structures, like giant walls of something or hidden black holes. See, this is what I mean about the science fiction movie stuff.
Well, it's not quite that dramatic. It's more like, imagine there are these huge clumps of something. We don't know what yet. But these clumps have a lot of gravity, and they're pulling on these stars, changing their paths so they don't escape the galaxy after all.
So we could be talking about discovering entirely new objects in our own galaxy. That's incredible. Okay, but for a second, let's bring it back down to Earth. This might sound like a silly question, but with everything we've been talking about today, warps, rogue stars, dark matter, should we be worried about any of this affecting us here on Earth?
Not at all. Don't worry. These are processes that happen on such a huge scale over such a long time that we'll never actually feel any direct effects. It's more like, think about watching a really slow, graceful ballet, but you're so far away that it's just beautiful and mesmerizing, not something that could ever hurt you.
Okay, that's a relief. So as we wrap up our deep dive into the Milky Way today, what's the one big thing you hope our listeners will remember?
I think the coolest thing to take away from all this is that our galaxy is way more dynamic and mysterious than we often think about. It's not just this static, unchanging thing up in the sky. It's constantly moving, changing, shaped by forces we're still trying to wrap our heads around.
And this new infrared map, plus the data from missions like Gaia, are giving us these amazing tools to actually explore those mysteries and rewrite everything we thought we knew about the Milky Way.
Exactly. And who knows what incredible things we'll discover next.
It really makes you wonder what other secrets are still hidden out there, just waiting to be found. And to everyone listening, next time you look up at the night sky, just remember, you're seeing a huge, dynamic, always evolving galaxy. And that, my friends, is pretty amazing. Thanks for joining us for this deep dive, and we'll catch you next time as we explore even more of the universe.